When you're reading a table, there are two questions that we're going to ask you. The first question is going to say, is this a quadratic? For it to be a quadratic, we need to pay attention to what we call your second step is going to be your second difference. In order to find the second difference, we need to find the first difference. So to go from 4 to 10, you would be adding 6. To go from 10 to 12, you're adding 2. From 12 to 10, you are subtracting 2. And from 10 to 4, you are subtracting 6. We can see that this first difference is not the same. It is not consistent, so we know that this is not a linear. If this were a straight line, those would be consistent. So now we're going to go into what we call your second difference. The second difference is going to be the same thing. We need to see what is going on. To go from 6 to 2, we are subtracting 4. To go from positive 2 to negative 2, we are subtracting 4 again. And to go from negative 2 to negative 6, we are subtracting 4. Because this second difference is consistent, you're doing the exact same thing each time, we would consider this to be proof that this is a quadratic. The second question that we would ask you looking at a table is, where is your vertex? You have a couple options. All of these are XY coordinates. You could go ahead and plot every single one of those points. Or you can look at your table and find symmetry. Symmetry means there's going to be a point in the middle that the left-hand side y values look the same as your right-hand side y values. So what I am noticing is that on this, we can see that I have a 10 here and a 10 here. I then have a 4 here and a 4 here. So that means there is symmetry around that coordinate 212. My vertex, I would then see or say, is 212. If you did want to go ahead and plot your points, you would have your 212, you would have your 310, and you would plot your 4, 4. And you would see that there was symmetry around that vertex at 212.